Hello and welcome to another installment of our Fireside Chat presented by CTIconnect. I'm Joey DeGraba, product manager here at CTIconnect, and today we'll be discussing the technology of Teragraph and the 60 gigahertz band it operates on to deliver fiber-like speeds. I'm joined today by David Botha from Facebook, who will discuss the origins of Terragraph and what brought about this powerful initiative, as well as some updates from the world of Facebook connectivity. I'm also joined by Craig Burgess of Siklu and Derek Underwood of Cambium Networks to discuss their approaches to the technology and share their vision on how Terragraph will revolutionize our industry. So first I'll turn to David from Facebook. Could you briefly tell the audience a little bit about yourself and your position at Facebook Connectivity?
Good, Joey. Hi. Thank you so much, first of all, for having me on the platform and for hosting this fun event. My name is Dave Botha. I'm a strategic partnerships manager at Facebook, and my area of responsibility is in the managing the partnerships we have with the OEMs who have adopted the Teragraph technology. So happy to be joined here today by both Siklu and Cambium. Just very quick on my background. I'm originally from an electrical engineering background, doing some design engineering work, originally defense industry. Eventually I moved over to commercial space, but stayed with wireless. My main focus has always been unlicensed IEEE technologies, Wi-Fi, sub-gig. Eventually I transitioned to product management. I joined Facebook 3 years ago as a product manager on Teragraph, and then transitioned to this partnerships role. And it's been fantastic being able to work with our ecosystem partners like Cambium and Siklu. And I'll get into a little bit later, the role that we as Facebook play in this Teragraph ecosystem.
Great. Thank you. So I think it would be beneficial for our audience to hear the story of Terragraph. Can you enlighten us on sort of how it began, including the move from 802.11 AD to AY and where we are today as this technology begins to roll out?
Certainly, yeah. So let me give a little bit of a background. First of all, I'll start with Facebook Connectivity, which is the organization within Facebook that where I work and that sort of initiated the Teragraph ecosystem. So Connectivity Group formed a few years ago at Facebook, and we have a simple mission, which is to bring more people online to a faster internet. That is the mission statement verbatim. And of course, it's aligned with the company's mission, which is to give people the power to build community and bring the world closer together. But not only that, it's good for our business as Facebook, right? Having good connectivity and good internet the globe around is just helpful for our platform. And the types of work that we do, basically, we look at the connectivity landscape and we seek to address various barriers that we see with a variety of tools and resources at our disposal, be they engineering, our brand, our reach, our financial resources, what have you. There are a number of connectivity initiatives underway at Facebook Connectivity. Teragraph is one of several programs that are active. Onto Teragraph itself, the Teragraph project was initiated a few years ago. Around 2015 is when we started the work in earnest. We were looking at connectivity, at least gigabit per second class connectivity, and what are the major barriers to accomplishing that worldwide. And the de facto standard for gigabit per second connectivity was, of course, fiber, which, as we all know, is expensive, takes a long time to deploy, so it's slow, deployment slow at least. And so we started looking at what are wireless, lower cost wireless alternatives to fiber that could begin to promise some of the same SLAs and performance capabilities. Very quickly, the 60 gigahertz spectrum emerged as interesting. It's widely available the world around. It's unlicensed in many, not all countries, but in many countries. And it's got a certain at least capacity. It's a huge chunk of spectrum, several gigabits, depending on which country you're in. So capable of certainly carrying, gigabit per second type capacity. Of course, there are challenges with 60 gigahertz. It's sits quite close to the oxygen absorption band. But these are not unsurmountable challenges, as we've seen already, in the legacy of 60 gigahertz products to date. It's a matter of managing those challenges with link budget and appropriate link planning. The main shortcoming that we saw with the 60 gigahertz as a promise to being an alternative, or let's say a complement to fiber, is that there wasn't a strong ecosystem and set of standards that would basically lead to a thriving industry of 60 gigahertz infrastructure. And this is where we decided as Facebook to jump in. So we started with, a fairly deep cycle of R&D, looking at what are the gaps in existing 60 gigahertz technology to fulfill this vision of say, last mile connectivity at gigabit per second class. And quickly we started basically evaluating what those gaps are and working up solutions to those. So for example, one of the concerns with 60 gigahertz is indeed it's a line of sight technology. It does have a tight link budget because of the oxygen absorption. So making the system resilient and let's say resilient to link interruptions and line of sight challenges was important. And that's how we conceived that a mesh approach to getting around line of sight obstructions and links going down, etc., would be key. Hence, we derived the mesh, which is encapsulated in what we call OpenR today. So OpenR is in fact a mesh and routing technology that we also use in some of our data centers at Facebook. So we leverage these technologies across different applications. Another challenge that we saw with legacy 60 gigahertz technology is in the realm of densification. You can imagine we're talking about adding a bunch of radio nodes in a mesh configuration. They might be quite close in proximity. And legacy 60 gigahertz products, basically operated on a contention-based MAC access. That is, the different radios would contend for airtime to be able to send data over the link. That is at least the 11AD gap, let's say, to densification. So for Teragraph, we realized we needed time slicing and time coordinated use of the medium. Hence, we designed the TDD, TDMA aspect of the Teragraph standard and contributed that incidentally back into the 802.11ay standard. So if you do go and look that standard up, you'll see a number of contributions by Facebook personnel for the transport layer changes to that standard. And then, of course, a technology that's going to be densely deployed in a mesh configuration also requires a certain new tool set for deployment and management. So as well as the mesh and the time division aspects of the Teragraph standard, we recognized the need to fill in a network monitoring component. So we this gave rise to what we call NMS, Network Management and Monitoring System for Teragraph. So these are the three components we basically at a high level define as the Teragraph standard today: the OpenR mesh, the time slicing in the TDD, TDMA, time slice use of the medium, and then third being NMS, control and management. After the R&D phase, we basically launched into development. This meant, starting to write software and firmware to implement the various aspects of the stack that were defined. Facebook also made some acqui-hires. We hired some industry experts in some of these fields. We got to work on reference designs. But in parallel to all of this technical development work, we also realized that we could add a lot of value by starting some regulatory advocacy work that is going to parts of the world where 60 gigahertz spectrum is not yet available for unlicensed use, and basically engaging with regional service providers, local entities, and of course the local regulator to make the case for bringing the 60 gigahertz spectrum into availability for unlicensed use. And then, really to wrap up the development piece, we had to decide how as Facebook we're going to offer this technology to the marketplace. How do we get all of this Teragraph stack out into the wild, so to speak? And for that, we decided to encapsulate the technology in a license scheme, a technology license. So the role we play as Facebook is, despite that we own or at least we gave rise to the technology of Terragraph, we actually license it out to our partners who then embed it into their products for commercial sale. These are royalty-free licenses. It's, again, our mission is to bring people online to a faster internet. So it's not a revenue generating mission. Here we have Siklu and Cambium, which are two examples of our licensee partners on Teragraph. So beyond or besides, of course, and even predating the partnerships under the licensing scheme, we needed to get the technology also implemented in silicon. So we engaged with silicon partners. Today, we partner very closely with Qualcomm as the lead silicon partner producing Teragraph capable chipset. And then as well as other components of the system. So there's a network processor, there's antenna modules, etc. Basically, we wanted to make sure that across the board for our OEM partners that there'd be a healthy supply chain of the relevant components to build a Teragraph product. So we began that work as well. Fortunately, all of that allowed that, by the time we engaged with our OEM partners, supply chain was fairly well under development, and they've been able to actually proceed in developing product with a number of the different initiatives that came up through that work. And then last but not least, in our engagement front, as Facebook, we also go out into the service provider side of the world and engage to make sure that there is certainly awareness of Teragraph, work with our partners, to our service provider partners, to ensure an understanding of how Teragraph can fit and solve some specific problems to their deployment objectives and connectivity objectives. And in the end, as you can see, our ecosystem focus is pretty broad. There's not just one type of ecosystem partner we engage with. It is, again, the silicon vendors, the OEMs, ultimate deployment partners, service providers. So it's all about ecosystem development from the standpoint of Facebook. And it's important to note that, and sometimes this is a little bit confusing, as to what role Facebook is playing here. We're not acting nor do we have intent to act as an OEM or a service provider directly. It's all ecosystem based and indirect work, and ensuring a thriving and healthy ecosystem of all of these different constituents is sort of key to our mission in Teragraph specifically. We're at a very exciting time, of course, in the overall project. We've had essentially the majority of our licensee partners, including Siklu and Cambium, announce and launch their products. And this has all happened in the last, say, 6 months, which has been very exciting, especially given the long time it's taken to conceive this technology. Work with getting chipsets developed is by no means a small and short-term task. So it's been a long journey, and finally seeing our partners launch and begin to deploy is just the most fulfilling thing. So we're very excited at Facebook for the current time that we're in. If I just take a look going forward, at and the role that we as Facebook seek to play, we intend to continue to be a steward really for this technology and support the ecosystem. Our goal on the program is to ensure that the ecosystem continues to thrive And that's going to mean obviously supporting the technology, evolving the technology that underlies it, ensuring that there's a flow of relevant enhancements, fixes as needed, and new features to address use cases. And through that, through our partnership with the silicon vendors and our OEMs, we believe we can take quite an active role in supporting that. Our regulatory advocacy work will continue. And as you've heard, the diversity of things we do is quite broad. So, I expect we'll remain active in a number of those fronts going forward to ensure the success of the initiative.
All right, great. Well, thanks so much for that. I'll move on to our manufacturers now, Craig and Derek Underwood. And if you guys could, just give a brief intro on yourselves. We'll start with Craig.
Oh, thank you. Thank you so much, Joey. And wow, I'm so honored to be here today. I'm Craig Burgess. I have been in the network building, either building it, selling it, designing it for, well, since the mid 80s. I actually started out in the building mainframes at NASA down in the Houston area there, and have just absolutely loved, the networking world, if you will. I started with Siklu about 6 years ago. I've worked for a number of manufacturers in my career, including Lucent Technologies, Motorola / Cambium, and then also Extreme Networks. And 6 years ago, I started with Siklu, and I got to tell you, I absolutely love what I do. I love the company, and like I said, I'm just so honored and excited to be here today. It's been our dream, Siklu's dream, to be on literally every rooftop, and so we continue to drive in those manners. So thank you so much for having me.
Yep. Thanks, Derek. There you are.
Thanks, Joey. I appreciate the opportunity that CTI has provided us to participate in this fireside chat. This is a very exciting technology, and I certainly thank my fellow panelists for what will inevitably be a productive discussion. I've been with Cambium since the inception and going back all the way to the Orthogon system days, and certainly seen a huge shift in terms of the use of fixed wireless technology to close that digital divide. With over 7 million radios now deployed worldwide, we've often looked at this 60 gigahertz band and thought this is going to be an important piece of the wireless fabric at some point. And I think when you look at the opportunity to partner with Facebook, the chipset, some of the work that Facebook's done with respect to reducing the cost of the chipsets, also the innovation and acceleration of technology on the AY chipsets. This was the perfect time to really enter the 60 gigahertz market, because we believe this is a very important technology for our network operators moving forward as the capacity for as the increase in capacity requirements exist.
Okay, great, thanks. Before I move on to the question section here, where we kind of dive into Teragraph, I want to go ahead and launch a poll. This will be kind of an easy one for our audience, just letting us know, giving us some feedback on where you're at in your Teragraph experience. If it's essentially just gathering information, or if you're further along the line of experiencing the product. So I'll launch that, and then we can go ahead and dive into the questions. So I'll stick with Derek to start here. Teragraph is bringing a different network architecture to the industry that some operators, may not be familiar with. And as we know, the pre-planning of any wireless network is often half the battle, but a very important step to success. When designing a Teragraph network, what should operators have in mind prior to deployment with respect to this new technology?
Yeah, it's a great question, Joey. I think the technology is one piece of it, but also the frequencies that we're operating in. One thing at Cambium we look at spectrum as one of the most valuable natural resources that our network operators have available to them. And when you look at the uniqueness of 60 gigahertz, it definitely creates a whole different set of challenges and opportunities from a design standpoint. As David mentioned earlier in his discussion, we are now dealing in a frequency where there's very high oxygen absorption. And with that comes pros and cons. And certainly when we look at the pros of that, we see the opportunity to deploy with very large channels, which gives us higher capacity with lower order modulation. But we also see an additional pro being this frequency reuse, right? Because signal's not going 5, 7, 10 miles like it is with some of our 5 gig and 3 gig bands, we have much better opportunity to plan networks from a frequency reuse standpoint. And again, really take advantage of that high capacity that we've never been able to look at getting a gigabit of capacity to a home. And I think that's really what 60 gig enables us as a result of some of the propagation characteristics. Now, the trade-off is the distances are very much, they're shortened significantly. We're not in a position where, again, we're moving from this high site design model that we've often deployed with 450M and EPMP, and now we're moving down to the street level. So the distances are shorter. As David mentioned, line of sight is table stakes. This is not a technology that we can deal with near and non-line of sight deployments. So as a result of that, not only are we going to have to deploy more devices, but we're also going to have to change a little bit the way that we design those networks. So at Cambium, we really look at it in 3 different aspects. We look at it from an RF perspective, which compared to a 5, 7, 10 mile link, it's not that difficult to design a 400 meter path. But it requires that we have line of sight. It requires that we have the link budget and that we've taken into account the rain attenuation for that path. So that's from an RF perspective, one that I think is, again, pretty intuitive and something that's pretty well known throughout our customer base. The second piece we look at is really the network planning component, right? We're trying to deliver gigabits of capacity, and now we're using multiple distribution nodes to relay, in some cases, around those obstructions, as David mentioned earlier. So creating the right type of network design from a capacity standpoint is a whole different component when you look at 60 gig and Teragraph networks. The third piece, and I think the one where there's as much of an art as there is as a science to these designs, is the redundancy and resiliency that this mesh architecture offers us. Again, down at the street level, you may have temporary obstructions from trucks or antennas get blown out of alignment. How does the design that we've put together help accommodate for some of those changes that may be temporary by rerouting and finding new paths? And that's really where the redundancy and resiliency aspect of designing the network come into play. And one thing, obviously, we've spent a lot of time as a wireless manufacturer, I think as any OEM has to do in developing tools that help us with these designs. And what we found early on in this process is it's again, taking a combination of this also requires a combination of tools. One tool such as See and Heat for LiDAR data, ground clutter to ensure you have that line of sight. One tool like Link Planner to help us with ensuring that we've got the link budget to support the throughput and availabilities. And then a separate tool that certainly Facebook has helped us with, the AMP tool, to support some of that budgeting and network capacity planning. And so we really look at all those tools together to help us kind of triangulate on a design. And certainly we believe that with the combination of those tools, we can build scalable, reliable gigabit networks.
Okay, great. So I'll move over to Craig and kind of the same topic. You know, what should operators really have in mind prior to deployment when they're approaching a Teragraph deployment, and how is Siklu kind of approaching that?
You know, thank you. Certainly, I want to echo my colleagues' discussion as well. You know, when looking at millimeter wave in general, it's a different animal. You know, altogether. We've known about wireline technology, for 100 years, whether it's copper or fiber. It hasn't really changed that much in terms of the deployment style. Yeah, connectors have changed. Cellular, 30 years, we've known how to build a design and monetize, the sub-6 ISP market, if you will, that's been around for 20 plus years. We mentioned, mesh networks. That was kind of a big thing 10, 15 years ago, has lost a little bit of favor, but I think we're bringing it back with Facebook and the Teragraph initiative. I call it Mesh 2.0, to be honest with you, because I lived all the scars from those days. And I know Derek has done the same. So, but anyhow, so, Siklu has rich history. This is our fourth generation 60 gigahertz platform. And, each platform continues to get better and better and better. And we're certainly ecstatic about all the different features that David mentioned that's bringing this to play. Some of the things that I think, you need to be aware of, when you're designing and moving forward is, you need to know your environment. A RF site survey is not necessarily relevant because 60 gigahertz, first of all, the physics of it are very, the beams are very narrow. The spectral reuse is, like I said, like Derek said, is off the charts. And so you really do need to know, are you in a heavily treed area, a lot of buildings? Is it, a lot of hills, etc.? So know your environment. You need to know, your vertical assets, your towers, your buildings, wherever your fiber is, whether you're going to use street furniture for deployments, hub homes, right-of-ways, etc. They all have different nuances about them that need to be considered in the design phase as well. And then, how big are your lots? How big is what's the densification of the area, that you're trying to reach? Those are things that you really do need to understand in the design phase as well, because it could change some of the aspects of the network. So, and what kind of service are you trying to deliver? Are you working with an enterprise customer, a high-end service, single-family home neighborhood? Is it, apartments, condos? Are you delivering in a trailer park, mobile home, if you will? Local government, school districts, etc. There's tons of things to consider. And then also, you need to understand your power situation. From the physical standpoint, you might need battery backup in some situations, depending on how clean your power is. And you might actually even need solar in some situations, but to continue to have resilient services. Some of the things that I love about, our platform is we have our Windy tool that allows you to, to start the process, and it kind of gives you a go, no go. It brings in all the elements in terms of, do we have line of sight? We're able to bring in LiDAR data, to help solidify. But what that tool does is allows you to design, at the desktop without going to the site to see, what you're up against out there. And then, it also spits out a number of operational tools that allow you to continue, like network configuration files, bill of materials, etc. But anyhow, you also need to look at this as a more like a organic fiber build rather than a, reach it from the tower from 5 miles away. It's a different animal, like I said. So, with a fiber operator, you're not going to try to reach a guy 5 miles over, right? You're going to try to reach the guy next door or across the street, down the block, etc. And that's kind of how you have to think from a marketing, sales, etc., and so on and so forth. So, but anyhow, so that's really, from our standpoint, we see the model, in terms of what you're able to, connect to, rooftops, street furniture, right-of-ways, etc. Those all have different nuances about them, advantages, disadvantages, etc. The beauty of some are better than others. We've been working at this model for a number of years now, and we've seen just so many different use cases out there that the other thing that you're going to want to do is, you want to design to resiliency, and you pay attention to that. And, with the Teragraph platform, the beauty of it is it has backhaul built into it. So, you want to design to that and make sure that you have your backhauls in order. And then, like I said earlier, battery backups can help in the resiliency as well. But the other thing that we found is the more dense the network, the less you're going to need those battery backups because you have multiple routes around the neighborhood or the environment. So the other thing that you can do with this that I love is, you can offer a tiered service, from a 100 meg to multi-gigabits of throughput. And, so the thing to consider there is the lower throughput, you can have larger cells, if you will, to reach. And anyhow, the other thing that our design tool allows you to do is, if you're going into a neighborhood that maybe you don't have 100% take rate, maybe you haven't worked out a deal with the HOA to get 100%. You can design it to a 10%, 20%, 50, 90%, whatever take rate, and build it such that that okay, if I build it to 10%, then I know I can continue to add. You're building the building blocks, and the beauty of it is there's really no waste as the system grows. And so anyhow, hopefully I've answered your question there, Joey.
Yeah, no, that's good. You mentioned some of the actual applications itself, and I can stick with you, Craig, just to kind of segue to that. Let's talk a little bit about deployment. In our previous conversations, we agreed that the bulk of the deployments will involve rooftops, right-of-ways, street furniture. What makes Teragraph radio deployment so compelling is that it can be a point-to-point, it can be point-to-multipoint, mesh. When you consider how flexible these radios are, how should operators deploy to really get the most out of the system in the field?
So good question. I think we've hit on it. Vertical assets are really, the critical point to your success in terms of the physics out there, the physical things out there. You really need to understand and know the advantages and disadvantages of each of the vertical assets that you use. You may need to tie up, real estate contracts, in some of the situations, et cetera. So, what we have found as well is, like, if you deploy in the hub home arena, with some of our providers, they've discovered where you reach a certain point where the hub home, everybody moves every 5 years, right? That's what Americans do. So you need to account for 20% of your population moving. And if the next guy doesn't want your service, then what do? That becomes a challenge. What we have found is the more dense the network, more than likely the neighbor across the street or what have you is already a customer. And so you may need to do a little bit of redesign, but that becomes, another topic, if you will. But anyhow, so, I say, use the right tools, to achieve the goal, is the other thing, right? Yes, this is a platform, but you also have to feed that platform. And I know Cambium and Siklu both have E-band, which is a great alternative to feeding a network if you don't have fiber in the environment. So you can get up to 10 gigabits of throughput. The beauty of the Teragraph is you can feed it with multiple different fiber pops, and so that creates an even more resilient network out there. So don't be afraid to use those. Use multiple fiber pops, if you will, or even multiple links into the network. So the beauty of our platform is the Windy design tool feeds the next software platform. So the Windy design tool spits out configuration files to feed the runner, such that we've created some AI, if you will, into the platform to where when your technicians go out to install Mrs. Jones' house on Elm Street, the system automatically knows, because again, we have some GPS coordinates capabilities. We built that into the design tool, which is interactive with Google Earth. And so the system automatically knows that you've installed Mrs. Jones' house and automatically puts them into the system, such that you don't need, your technicians don't need to understand RF or IP of any nature. They need to have ladders and hand tools, and that's pretty much it. So, you know, one feeds the other from our solution standpoint, you know, from our operational software. So hopefully that addresses your.
No, yeah, it does. Derek, I'll turn to you and kind of ask the same question. You know, what should operators consider, you know, when deploying this product, and you know, maybe give a little bit of Cambium's approach to that.
Sure. So first of all, I'd like to say Facebook, and David mentioned this, they give us a great reference architecture to build a platform. And I think, you know, when you have an ecosystem like this and you have quality manufacturers like Siklu and Cambium participating in this ecosystem, it really pushes us to innovate off of that reference architecture. And so one of the things that we spend a lot of time looking at in the development of this product is the years of history we have with customers deploying micropop deployments using some of our legacy technologies. And while it's not the same micropop technology or architecture, there are some similarities. And Craig is absolutely right in the sense that we are having to use completely different types of infrastructure, street poles, homes as distribution nodes. And so we looked at that and we said, okay, let's build a product that really takes this reference architecture, takes some of the years of battle wounds that we have in deploying these micropops and with our customers. And let's think about the things like power consumption, right? Where you don't have the same level of power necessarily at some of these sites. Let's look at footprint of the equipment, where it's going to be going on something that has to be aesthetically pleasing. And then let's also look at the fact that we just have a lot more devices out there. So when you look at, we wanted to be efficient as we could in terms of cost from a distribution node standpoint, just because, you know, these networks are going to require a lot more equipment. And I think one of the other things that's a little unique about this is access to these sites. And Craig mentioned the density of the network and how important that is. And we completely agree with that because there may be sites that you need union workers with bucket trucks to close off roads in order to get access to some of these locations. And that's not feasible. So what happens to client nodes that may be connected to a DN that needs some work? And so I think all those things have really gone into us taking, again, this reference architecture that Facebook has given us, but also modified that based on the markets that we want to go after. And you mentioned the point-to-point, point-to-multipoint, and mesh. And I think we're going to talk about mesh a little bit later on. But just in terms of having that flexibility, it's powerful. But I think it's on us all as OEMs to ensure that it's simple to deploy, that it's simple, that operators don't have to make a lot of choices about how they configure a piece of equipment to fit into the network. And I think that's really where you're going to continue to see evolution from us as OEMs. I also think there's one thing when you look at this technology and certainly these higher frequencies, and we even see it in some of our licensed microwave technologies, that antenna alignment gets to be much more of a consideration. And so again, on us as OEMs to figure out a way to simplify that and to create a little bit more tolerance for some of these locations. And I always think about, we're so used to going up 200 feet on a tower, bolting equipment down, blasting out as far as we can. And when you have that type of a deployment, you don't worry about things as much like tower sway. We know that's part of it. We build that in. But when you're on a street pole and you've got trucks that drive by, and all of these things are very different from a deployment standpoint than we typically see in our fixed wireless architecture.
Yeah, and you mentioned some of the mesh stuff. Teragraph involves the concept of mesh technology, and while that's not a concept that's new, each of you offers the mesh controller, and with new systems come new ways of management once hardware is in the field. We saw a big challenge with LTE cores coming into our space, and there was a lot of learning curve involved with that. But can you help us understand the complexity, or maybe the simplicity of managing a Teragraph network? After it's all out there.
To me?
Yes.
Okay, perfect. Yeah, so Craig said earlier Mesh 2.0, and I think it's interesting to see the discussions we've had, to hear the discussions we've had with customers and some of the aversions to mesh. And this is certainly not the mesh technology that you're used to. And a big reason that some of the traditional legacy mesh technologies received such a black eye is they were contention based. And when you have that contention-based meshing technology, the performance isn't very good. And what you find is losing 1/n number of hops in bandwidth is not usable. And so with the work that David mentioned earlier, I think you did a great job of kind of outlining the time slicing, the scheduling, and really how we do have backhaul built into this technology. And that we can maintain that integrity and that capacity over multiple hops. That's a huge change for this Teragraph meshing solution and technologies that we may have been familiar with in the past. I will say again, going back to my comment that this is a reference design, right? And some of the fundamentals of Teragraph are in all of our product. But I think there's still opportunities for all the OEMs, and certainly, we've taken this approach to try to simplify it as much as possible. And at Cambium, what we've done, we try to think of it not as a mesh controller, but really as an end-to-end controller, irrespective of what architecture you're deploying in. And what that provides us is a single place to go to make those configuration changes, so that those devices on the network pull that configuration from this end-to-end controller, again, irrespective of the architecture. And so it's the idea here is that we get to a point where you don't have to put in static routes. We have dynamic routing. We have the ability to take this complex mesh design and simplify it using this end-to-end controller. To the point where you can actually go out, factory reset a radio, and that radio will pull its configuration from the controller. And at Cambium, what we've done is we have used our CN Maestro and Maestro X, which are really our single pane of glass for all of our technologies. And that's really gives customers that seamless management, independent of what products you may be deploying on that network. And so Maestro Essentials and Maestro X both act as our end-to-end controller. And this, I think, is probably the single biggest area that you're going to continue to see evolution in terms of simplicity, in terms of customers being able to put this network out, create that redundancy and resiliency, and not have to think a lot about which devices are talking to which devices. So I think our platform from a management standpoint definitely gives us the ability, again, to look at all those devices without having to go in and configure and manage an individual device. We still have, and there's been a lot of discussions around the layer 2 versus layer 3 deployments that we're seeing in the field. And I think one thing that we focused on at Cambium is giving customers the ability to deliver that IPv4 and IPv6 dual stack without the need for any additional devices. Because we do recognize there's going to be cases where a simple layer 2 configuration for maybe a video surveillance network or small campus connectivity can be very valuable. And so having that built into the network management tool and the end-to-end controller, I think is something that we've put a lot of work and investment into. We'll also see that the network management platform starts to expand the capability as we add features like channel bonding, as we add features, as I mentioned, like the dynamic routing and not having to go in and configure routes on your meshing architecture. And so again, seeing Maestro Essentials and Maestro X both serve that function for the cnWave platform.
All right, thanks, Derek. So I'll move over to Craig, and if you want to kind of address the same topic of management, you know, and maybe how Siklu is approaching it to make it easier for operators and tackle this new type of technology.
Yeah, absolutely. Thanks, Joey. And so yeah, you know, when I heard Facebook calling this mesh, you know, I know Derek is probably in the same boat. You know, we cringed, you know, because we've got the scars from it, you know. So, but anyhow, you know, so it can be a very, very complex technology and design. I mean, Facebook has worked on this for, you know, better part of 4 years now, and Qualcomm and a number of manufacturers, and so we're now to the starting line, if you will, and off to the races. But nevertheless, I think what Siklu has done is take from an approach to really help simplify things for our customers. We first of all, we started, you know, we're starting with a layer 2 approach, if you will, IPv4, and we will add IPv6 and higher advanced layers to the platform on the same on the same hardware, by the way. So it's built for growth. And then we took a little bit approach in that you know, we've included some off-the-shelf or you know, some known technologies that have been around for, you know, layer 2 technologies that have been around for 20+ years, and essentially added some artificial intelligence on the node itself to, you know, which is your OpenR type stuff, to help make decisions, failover decisions, etc., on the node. And so, so it helps streamline things. By the way, our platform can work with or without a controller. The controller actually helps add, basically what it does for you is it helps streamline your operations. In other words, like I was saying earlier, the hand in glove approach to our design tool, our EMS, NMS, and also our runner tool allows the system to where you can set the policies, procedures. You can also set what network elements get what type of configuration files, etc., and that's all pushed automatically, basically, when the network element is added to the network. So there's a lot of efficiencies that we've put into our solution to help really maximize your total cost of ownership to where you're not bloating your customer service department or your NOC. And so that's you know, some of the things that we see, the complexities of the Facebook, you know, the Teragraph platform. Actually, there's complexity, but we use those complexities to make it simple. And I think that was actually the goal for Facebook to do, is to, you know, to create this super complex inside, but, you know, allow us as manufacturers and builders to make the complex simple. So, and I think, you know, all of us, that's our goal, right? So.
Okay, thank you. So I think what we'll do is we'll move over to some questions here submitted by the viewers, and I think I'll toss one back to David here. There's one here about whether the Teragraph network will be rolled out in a network switch platform that is wireless agnostic, or will it stay within the 60 gigahertz radio sphere? If you want to maybe comment on that a bit.
Sure, that's a great question. You know, from Facebook's perspective, we certainly zeroed in on the 60 gigahertz piece of spectrum for reasons I spoke to a little bit earlier. But, you know, as we've developed the fuller Teragraph stack, as we call it, we have also recognized that different elements of that stack can play a pretty compelling role in, you know, if operating at other frequencies. So we do have, you know, dreams and at least a openness to looking at porting different parts of the Teragraph technologies to different frequencies. It's currently not within the Teragraph, let's say, IP framework. Today, Teragraph does imply just 60 gigahertz. But I can certainly foresee in the future us, having different parts of the Teragraph value stack operating at different frequencies.
And will Teragraph products be interoperable between vendors, given the way LTE might be standards based?
Yeah, that's another good question, and one that comes up a lot. So let me talk to that a little bit. What we as Facebook have done as far as interoperability, we do see that as important. But at the end of the day, what we're delivering are a set of building blocks that don't make a complete product. So Siklu and Cambium have taken these building blocks and added a lot of their own product attributes and value add to make a complete product. What we've ensured on the Teragraph standard and with our licensing scheme is that there's interoperability between basic implementation of the building blocks. So, none of our license or let's say technology adopters can change anything such that interoperability would be broken. For example, any two Teragraph units could certainly form a link between one another. But now where things start to become tricky with interoperability is in that realm of value add, right, where the different OEMs are differentiating, adding new features, and they may do so in different ways. And that's essentially going to break what we would call service level interoperability. So today, certainly two vendors' products are unlikely to interoperate out of the box configured with their full stacks, but their building blocks can interoperate. And I know that's not practically deployable, but at least the foundation is there. And as Facebook, what we're looking to do is, obviously we need to incentivize and figure out a scheme that works for everybody to have full service level interoperability. So we're looking at how we can do that within the ecosystem. But as of today, whether or not two vendors' products will interoperate at a service level directly, the first answer is no, that's not automatically guaranteed. But the second part is that is a conversation that can be had with both vendors. And it's in the realm of doable, let's say, because the building blocks do interoperate.
Right. Interesting. So I'll kick one back over to Craig. It looks like a lot of questions coming on. This system is made more for an urban deployment rather than rural. And I guess some rural operators are wondering if this product is perhaps too niche for them. Can you speak to that a little bit and how maybe a rural operator might take advantage of this?
Oh, absolutely. I will say out of the few hundred providers I've introduced this to so far, the ones that are the most excited about it are the rural operators. If you think about the smaller towns, this is a perfect application to be able to go and install a unit, a node in the middle of town. Jade Communications brings to mind one down in Alamosa, Colorado, that has used our platform for a few years now to reach all of the above. Serve from business to government to single family homes, MDUs, etc. And this is a perfect application for all of the above, I would say. So if you think about it, not everybody lives on a ranch or a farm, so most of your population, lives, close to a neighbor. They're not living on 10-acre lots. It's generally, less than a 1-acre lot. And so that's where this is relevant. I always tell people, we budget for that. If you're trying to reach the farmer with fiber, then I'm a great alternative, from a cost standpoint. But not many providers are reaching the farmers out there, right? Sorry, farmers.
Right. Derek, do you care to comment on that, just to kind of help our viewers understand the use cases, I guess, more in a rural environment?
Yeah, I think what we're seeing too is that folks are moving further out. Obviously, the pandemic has had an impact on that, but what we're also seeing is that this is a great technology for neighborhood deployments. Right, when you're able to use homes as repeater sites and you're able to use homes to redistribute that network and get around line of sight issues. Yeah, you may be a rural operator today, but finding those pockets where you have 10, 12, 14, 16 homes, it becomes very doable. And I agree with Craig's point that if in fact you are looking at reaching these sites with fiber, this is a great alternative. And we believe that the other place that we think there's a really good opportunity is just in extending that fiber where we're trenching that last piece under rail or across a river doesn't make a whole lot of sense, but you can just augment that fiber network and extend that and do it quickly. In fact, I live in a community where we have been waiting for fiber to be run now for, it's been about 4 months since they started the project to get to 12 homes, right? And they've got fiber, they've got a point of presence. How simple would it be for that operator to extend the multi-gigabits of capacity that they have, and instead it's taken 4 months to tear up the roads, and so I think this technology provides a real alternative for those types of applications. And I certainly don't consider myself living in an urban environment, but I think it's that it's pockets of homes, it's pockets of users that this technology works very well to extend fiber.
Craig, in some of our discussions, you had mentioned that there's actually going to be some challenges with marketing, the capability of the product versus the product itself. And I wonder if maybe you could touch on that a little bit, because I think a lot of our viewers want to know what are the biggest changes to mindset, I guess, when approaching this product, and that was interesting.
Yeah,
if you want to touch on that.
I think the product is one thing. I think, delivering the service is another. And being able to deliver that service in mass is quite another, right? And so that's where we see, we've been working with the AD chip now to help providers reach, all of the above, so to speak, for a few years now. And, some of the things that we've seen is really, the challenge, if you can't get, the HOA to sign on the dotted line to reach every rooftop, then, there can be great challenges in growing the business. And so we just see that it's not your traditional service provider, even wireline or wireless service provider type marketing. You really have to get almost guerrilla marketing sales in nature, and in order to get the take rates up, including not just door hangers but knocking on doors. It's that aggressive. So if you want your take rates to go up, because it's a competitive environment. Now, if you're going into a neighborhood that's completely underserved and has dial up, then more than likely you can get 50%, 60, 80%, 100% take rate. So your marketing doesn't have to be as guerrilla, if you will.
So I guess we'll kick it over to Derek. Do you think that the radios themselves are relatively flexible in terms of backhaul? Does it need a fiber network to back it up? Can it be run off wireless? Can you kind of talk a little bit about that and how it relates to the overall structure, maybe of the network behind the radios themselves?
Yeah. So again, being in the wireless industry as long as I have, I feel like we're constantly having that discussion about fiber versus wireless, and I think this is to me, this technology really bridges the gap in terms of we're no longer competing head to head with a fiber solution. It's very complementary, right? We can leverage that fiber network that's in the ground to extend places where we can't get it. Or another area where I think there's a huge opportunity is in doing some of those neighborhoods where you're looking at, if you're an operator and say, I'm going to go into this neighborhood and build out a fiber network, why not put a 60 gig solution in place ahead of time to, again, see what those take rates are before you commit to starting to trench, et cetera. And I think this is the time to market is so much better with a solution like this. The reliability is certainly there. I think overall, and we talk about this all the time, the fixed wireless industry has really been legitimized. When you see the government subsidies, the networks that are being built today to serve these underserved communities, we really don't have to fight that battle of, does this technology work? It certainly works. And this is just really a breakthrough technology in delivering gigabit or multi-gigabit levels of service.
All right, Craig, maybe you could give a little bit to that and just kind of talk about sort of how this is going to perhaps bridge people into maybe a fiber network, or it's interesting. A lot of the grants that we're seeing are obviously paying more for fiber, but this could be the wireless option within that ecosystem. Can you speak a little bit to that?
Yeah, absolutely. Well, I consider how much money has already been spent on fiber, right? And we're not 100% connected. I mean, it's if you think of it, if there's a business model that the tier ones and the fiber players, can reach, then we should be at 100% capacity. But I think what this platform does is, just like Derek said, it's a perfect extension to fiber, in that it gives you, fiber-like performance, if you will, with multi-gigabits of capacity, super low latency, the resiliency because of the way the chipset is built, and Facebook has built their reference design in that you have, built-in backhaul to the radio. I tell people, you'd have to spend 1,000 times more to build a fiber network that's as resilient and is capable of delivering like this Teragraph platform. It's scaled beyond, believe it or not, than fiber. And I have a fiber background.
Right. Well, I think we've addressed pretty much all the questions here. There was one here. Verizon found that with beam steering, they could utilize reflective non-line of sight paths at 28 gig with adaptive SNR. Does this work at 60 gigahertz? Maybe David, you can take that and just kind of talk about maybe that trend that we've seen in 28 gig and relate it to this.
Sure. And, specifically this question about non-line of sight or reflective paths between units, those physics do work as well at 60 gigahertz. So indeed, that's possible. I wouldn't say it's a deliberate, planning strategy to go and look for reflections, but and maybe another comment I'll make, we've spoken quite a bit about some of the challenges that Teragraph stack solves, but at the end of the day, the service provider, the customer, should be pretty abstracted from that. The Teragraph technology takes care of a lot of that complexity.
Yep.
And this particular question is actually a good example of that. In the deployment, you wouldn't have to worry about ensuring that, you've got a reflective path versus a line of sight path. The system is going to pick the best path of all the different, pencil beam options that these phased array antennas have. So I will say anecdotally, in the reference designs we've built at Facebook, yeah, we've seen on occasion you do pick up a link that's a reflective path. So it works, but again, it's not necessarily something you want to nor necessarily have to plan for.
I'll kick this over to Derek. Any foreseeable plans to have a Wi-Fi and GPS chip built into the radios, just sort of a combo play?
Yeah, I mean, I think, we certainly look at these options. And I think when the comments you made earlier, the question that was brought up about interoperability, and I thought David's answer was very appropriate, but you also want the OEMs to continue to innovate, right? And then that innovation is really what's going to drive advancements with the solutions. And so there are opportunities for us to look at those types of things, right? We have a full portfolio of Wi-Fi products today, with a network management platform that supports both technologies. So it's certainly not inconceivable for us to do. And again, I think those are some of the reasons, while we do have a great reference architecture, you want us to continue to innovate. You want us to continue to come up with ideas that might create solutions for customers that solve a problem.
Can I make a comment about a dual band?
Mm-hmm.
We at Siklu, we've been, ever since I've been on board at Siklu, we've discussed this topic, and I've settled on that the two frequencies they operate so differently that they're just very difficult to design, manage, and build and manage dual bands like this. In fact, we've seen a couple other manufacturers do this in these frequencies, and the providers that I talk to tell me they just end up shutting off the 5 gigahertz. So because it ends up diluting or polluting their other 5 gigahertz initiatives. So it's to me, it's like, oh yeah, that would work. But when you start really dissecting the frequencies and how they operate totally different from each other. And so that's what makes it, to me, a challenge to integrate, in a point to multi-point environment, I should say. So.
Right. Okay, well, I think that's pretty much coming up against the time that we have. I want to, thank all of you for joining today, all of our viewers, and of course our panel today. It was a really great discussion. I think that we'll definitely want to revisit this as time goes on, as more people start to deploy this, and as the products roll out. We'll definitely have follow-up discussions on how well it's working for everyone, and as people get to experience it. I'll go ahead and launch a poll here just for any of our viewers who want to have more information, and we'd be happy at CTIconnect to provide them with any information, facilitate that. So I'll go ahead and launch that other poll and leave that up there for a little while. Other than that, again, I appreciate everyone's attendance and attention today, and I want to thank our participants. So have a wonderful day, and we'll talk again soon.
Thanks, Joey.
Everyone.
Thank you, Joey. Thanks, everyone.
Yep. Bye-bye now.